All right. Little review of graphing.
A or Z?
B. So let's look on this left one. We're going to jump to some colors here. We're going to draw over our box here with colors. So let's go blue, and I'm going to have the z-axis be blue. So z positive up here, z negative down here. So with a blue pen, draw all your vertical lines that are visible in blue. Now, so I'm drawing 3 of them. The 4th one, I'm going to draw dotted, because this 4th one is not visible. All right, now let's pick another color for horizontal. I'm going to pick red. So my y positive is on the left, on the right. My y negative is on the left. So make your horizontals red. And once again, the one that you can't see, make it dotted. All right, need a third color for the other dimension. What do you want to use? Green, okay. So we're going to go green. So that's our x. Remember, x negative is in the back, and x positive is in the front. So there's your greens. And I really think that your colors are going to help your dimensions. So what are the coordinates? I guess we should label some corners. I'm going to go to black to label my corners. A, B, C, D, E, F, G, and our invisible one at the back, we're going to call H. What point is the furthest away from the origin?
D.
Do we agree it's D? All right, so what is the x coordinate of my D? What's our x? How far out? 1, 2, 3, 4. What's the y coordinate of my D? Remember, the y is sideways.
3.
I heard 3 and I heard -3. Is it going left or is it going right?
Oh, -3.
It's going left, so -3. And is my graph above the horizontal or below the horizontal? It's below, so what's my z coordinate? -2. Make sense? Lydia, you're giving me that look like I'm not quite sure.
I'm trying to figure out how it's going -3.
Okay, so let me do some counting here. Here's 1, 2, 3 on the red. On the green, we have 1, 2, 3, 4 forward. Remember, forward is x. And then on the blue, we have 1, 2 down. Does that help?
Yeah.
All right, let's slide over to here. Tell me what you notice about this graph.
It's not 3D.
Well, it is 3D.
It is. It's just not a.
It's just not a what? It's not a box.
Yeah.
Okay, so what dimensions do we have? Let's stick to our dimensions. Red is y, so I'm going to label them with color. Red is y, z is blue, and x was green. So, do I have an x dimension? Do I have a forward or backward? So let's draw that. Here's my forward x. 1, 2, 3, 4. So my x value is 4. Do I have a horizontal, Stephen, side-to-side component?
No.
No? Okay. So what's my coordinate then?
0.
0, right? So we put a 0 in. Switch to blue. Do I have a vertical component up or down?
Yes.
I do?
Yes.
So let's draw a vertical component. Up, and it looks like I'm only going up 1. True? And I guess I should redraw that one horizontally. So if I label my points in black, I have point A, point B, point C, and point D. Which point is furthest away from the origin? D is on the x-axis. I believe it's C. So C is this point. This is point C. And over here, this was point D. Now, do the colors help you kind of get your layout?
Mm-hmm.
Does this one have any dotted lines on the right? Or can you see the whole three-dimensional piece of paper? Because there's no depth to it, true? There's no depth. All right. Let's go down here now and let's practice doing one of these. 4, -3, 4, -1, 3. So let's label. Once again, our vertical is Z, so let's put Z positive up there and Z negative down there. Our horizontal was red, so Y positive and Y negative, and green, X negative at the back, X positive at the front. Who can do my X? Someone hasn't kind of jumped in yet. Lydia, go ahead.
It's 4 down.
So I come on the x-axis, so I come 4 towards me.
Yeah.
So I'm going to tick off 4 hash marks here. 1, 2, 3, 4, and I'm going to draw that line. Okay. So I'm 4 forward. Now let's go our y value. Someone else. Where am I going for my y value? Jonah? Left 1. Okay, so everybody go left 1. And now we're going to practice drawing that parallelogram. Go down to the 4 and go left 1. About the same length as the other red line. What should I do with it? Connect those two? Draw a green line. I can always make it dotted later, so for right now I'm going to make it solid. Your diagram at this point, Alexa, should be a parallelogram. Okay, it should look like a parallelogram. Now, am I going to go up or down?
Up.
Why up?
It's positive.
Okay, so go to your third component, which is blue, and go up 3 marks on your vertical Z. So we have this vertical line that's 3 bars long. From each of your corners, you need to go up 3 bars. So go up 3 bars from each of your corners. Then you're going to connect your corners with the same red on the sideways and green on the diagonals. And now we have to determine which lines are dotted. So I'm going to label our corners. A, up here I'm going to call B, up here I'm going to call C, up here I'm going to call D, down here E, down here F, right there G, and down here H. Which ones are dotted? Talk to me. EH is dotted. Do we agree? EH is behind what we can see.
Mm-hmm.
So take your white pen and put some white spots in there. If you don't have a white pen, create one. You create a white pen by going to your draw board. We'll do it together. Select pen, select black, and then you can choose white. Okay? All right, what else is dotted? Zach gave me one. Somebody else give me another one.
Back.
Which one? Give me letters.
CH.
CH. Do we agree that CH is dotted? You really can't see it. So CH is also dotted. Good. There we go. Is anything else dotted? AH. Is that you, Luke?
Yeah.
All right, I would agree. AH. I can make that dotted. Now the box just kind of jumped out at me because now I can kind of see what I don't see and see what I can see, and it's a lot more consistent for me to grasp. What is the point that is in question then? A, B, C, D, E, F, or G, or H?
D.
D? Okay, so point D is our critical point. So what is this going to be? This is going to be point D, right there.
So is it just like that is what that is?
Mm-hmm. So if I asked you to graph point D, the best way to represent it would be like this. Is that doable?
Yeah.
How do you guys feel on this? We've done this now 4 days in a row. Is it getting better?
Yeah.
All right. Let's slide over and let's look at our next one. Once again, just to be consistent, I'm going to make Z positive up here, Z negative down there. On the horizontal, Y positive, Y negative, X negative, X positive. Just keeping those colors consistent. All right, let's get some new people here to talk us through. Who can start me with the X coordinate? Paul? 0. So do I really do any green drawing? No. Okay. All right. Who can do me the Y coordinate? Someone new. Come on, jump in here. Go ahead, Layla.
Would you go back to on the horizontal line or the Y?
Okay, so I'm going to go this way.
Yeah.
So I'm going to hash off 1 and 2. Okay, so I'm to the left. All right, what about my Z coordinate? Where do I go? Grace, Anna? Down 3. Grace, your voice has gotten much deeper. Down 3. So I guess from the other red line, I need to go down 3 and over. Okay. Where is that point? Describe it with words. Where is it? Where do you see that point, Trevor? Think three-dimensional. Where is that point? Just describe it. And there is not a good copy. How would you describe this point down here? Where is that point?
It's to the side and down.
Okay, so it's below the horizontal plane?
It's not coming towards us.
It's kind of on that vertical plane. Okay, so it's below, right?
Yes.
So do you see it down?
Mm-hmm.
Okay, Luke?
Shouldn't the negative 3 line be blue?
You mean this line?
Yeah.
It is. Can't you tell?
Bad accent.
I know. See, you weren't looking with one eye. If you had been looking at it with one eye, you would have seen that it was truly blue. But you were just green with envy. All right. How do you feel here?
Good.
A couple people asked if we could practice this a little bit. Did this help? All right. From here, all I can say, guys, is practice. Draw a grid, pick a point, practice. Draw a grid, pick a point, practice. And you just need to practice until this becomes just part of your comfortable stuff as we move forward. All right, we're going to put graphs away for a little bit, and I want to do a little bit of review here back from Friday, since it's been 5 days since we were together. I picked out a problem this morning. I created this. I hope it's going to work and not give us fractions. So we're gonna go on this. But once again, what we have here, Una, is I have 3 planes that are intersecting in lines somewhere. So our first goal is to eliminate one of the 3 variables twice. So Madeline, help me. You want to eliminate the x's or the y's or the z's? Which one looks easiest?
The easiest, probably the Y.
All right. Would you guys agree with her? I see a positive y, I see a negative y, that'll be easy. And then probably the negative y and the 2y. Okay, so let's label Madeline. Give me some colors. What do you want the top equation to be? What color?
Let's do blue.
Okay, top equation, everybody, is blue. Middle?
Red.
Red. And bottom?
Green.
Green. Okay, so what is your first step going to be, Madeline?
So I would take the blue and the red equations and then rewrite them out to simplify them.
So 2x plus y minus z equals -6. And the red equation, x minus y plus 4z equals 17. And once again, your objective is eliminating the y value. That's our objective here. Do you agree I have 3x?
Yeah.
No y's. How many z's?
3Z.
3z equals 11. All right, so there is what I would call Una equation A. What we just did is we took one plane, Una, we intersected it with the second plane, and we now have a line. We have one line. My next step is to get another line using different equations. Now, Sebastian, what equation have I not used yet? The green. Okay, so let's copy the green down at the bottom. -3x plus 2y minus z equals 7. All right, coming back up to the top. How are you going to combine green with something else to drop out the same variable again? Stephen, give me any thoughts? I want to drop green out and I want to drop out the y's. Do you want to use the red or the blue?
The red.
Okay, because you have a negative y there with a positive 2y. So what are you going to multiply your red by, Stephen? I completely agree.
2.
Okay, so let's put a 2 out here with an arrow. So that's going to become, ooh, we're a long ways down, 2x and then minus 2y and then positive 8z and then 34. Do you agree? All right, so Stephen, do my y's drop out?
Yeah.
Okay. Talk to me here, Moss or Paul. Can you give me my resulting new equation? We're going to call it equation B. How many x's?
-1.
Okay. No y's. Moss, how many z's?
7.
7 z's. And 41?
Yeah.
Suspiciously large. All right, here we go. 3x, 3z equals 11. -1x plus 7z equals 41. Did I copy those right? Okay, do you want to drop out the z's or the x's? Give me some opinions here. X's?
Yes.
Why the x's? Why do you choose the x's? I agree with you, but why do you choose them, Krista?
Because you don't have to multiply both of them on another. It's just easier if you.
So just one scalar. All right, so my scalar is 3.
Yes.
So -3x, positive 21z. 3 times 1 is a 3. 3 times 40 is 120. I'm combining that with 3x, 3z, and 11. That's 24z equals 134. Please let 134 divide by 24. Does it? What's the answer? 5.583. So I'm not seeing it dividing nicely. Now, just because it's a decimal doesn't mean it's wrong. Remember, what did I say I did this morning? I just did what? I just created this thing on the fly. So the likelihood that this is going to be a nice neat answer. So before we go back, let's just check and make sure we didn't make any mistakes. 2x and x is 3x, right? Did we copy anything wrong?
No.
Okay. 3z and 11. Is that right? Did we multiply the red correctly by 2? Red by 2. 2, 2, and 8, and 34. 2, 2, 8, and 34. Okay? Negative 1x, positive 7z is 34 and 7, 41. Okay, we're just checking before we go further. All right? We multiplied by 3, negative 3x, 21, 123. Okay, 24. Okay, looks like we're okay. So let's go back now, and now let's solve for x. Here we go. 3x plus 3 times 5.583 equals 11. You're going to need your calculators here. Three times 5.583, 16.75. Equals 11. So minus 11. So 3x equals negative 0.5749 divided by 3. X equals 1.916. Negative. Thank you. All right. Still a valid number. So now I need to go back and find what value? I've got z, I've got x, I need what? Y. Which equation is the easiest to get y?
Blue. Maybe.
I think 1. Blue?
Yeah.
Did you say blue or 2? Okay, so 2x. So 2 times negative 1.916 plus y minus 5.583 equals negative 6. So negative 6 minus, plus 5.583 plus, I can't do this all in my head, 2 times 1.916, 3.832 negative, plus y minus 5.583. 5.583. Do you get 9.45? 415. So we add that to negative 6. And so I get y equals negative 3.415. Okay, now these are nasty answers, but they're viable. How do we make sure they work? We solved it using what? Blue. So what do we have to check it using? Red or green? What do you want to do? Red? Yes, ma'am.
Wouldn't y be a positive 3?
What's that?
Because if you add 9.415 to negative 6, wouldn't y equal
A positive? Okay, good call. Good call. All right, so let's check this. And you said you want to combine this with what equation? Red? Since we solved it with blue. So I'm going to switch to red. And the red equation is x minus y plus 4z equals 17. That's a big thunder. All right, so negative 1.916 minus y, which is 3.415, plus 4z, which is 5.583. So we're going to plug all this in. Negative 1.916 minus 3.415 plus 4 parentheses 5.583. 17.001.
Yeah, close enough.
So why is it 0.001?
Because they go all the way.
Yeah, did we round a little bit?
Yes.
But what's the good point?
17.
Is that it?
Yes.
Yeah, we got it. So we can write down our answer. All right, here we go. My x, negative 1.9. My y, 3.4. My z, would you say 5.6?
Do we have to round the answer?
Well, you'd want to at least be to the nearest tenth. You know. Now, if you put those numbers in to check it, would your answer be 17.001?
Yes.
No, it might be 17.1 or 16.9 or. So the more accurate you are, the more accurate your answer is. But the point is, did it work? Yeah. Do we check it in a different equation? You bet. All right, if I'm trying to determine if Alejandra and Haley have the same last name, and I say, Alejandra, what is your last name? Rivera. And so I'm going to confirm that they have the same last name now, and I go back and I check my answer, and what is your name? Rivera. So I got the answer Rivera twice. So for sure, Haley and Alejandra have the same last name. Is that almost ludicrous? Okay, I have to ask Haley. You've got to ask the other equation to check. So it's really, really important there. All right, questions? Any questions? All right. We'll stop.